In this lesson, we'll use the definition of the logarithm to convert between exponential and logarithmic equations and to evaluate logarithms. First, let's recall the definition of the logarithm. For all positive numbers b, with b not equal to 1, and all positive numbers y, the equation x equals log base b of y, or the base b logarithm of y, is equivalent to the equation y equals b to the x. We call this number b the base of the algorithm. We've looked previously at the exponential equation 2 to the x equals 5. In logarithmic form, we've seen that this equation is rewritten as x is equal to the log base 2 of 5. And we've said that as a decimal, this is approximately equal to 2.322. And as we go further, we'll discuss how to obtain that decimal approximation. But for now, you can verify that this is a reasonable decimal approximation by checking 2 to the 2.322 on your calculator, and you get a number that is very close to 5. So the key to focus on now, again, is converting between this exponential form of the equation y equals b to the x and the logarithmic form x equals log base b of y. So here we had the exponential equation 2 to the x equals 5, and we write that in logarithmic form as x is equal to log base 2 of 5. Our next exponential equation is 4 to the x equals 64. And now notice this exponential equation we actually can solve because we know that 64 is the same as 4 cubed. So equating our exponents gives us x is equal to 3. So let's rewrite this exponential equation 4 to the x equals 64 in logarithmic form. So here our base b is 4 and our y is 64. So this is going to give us the logarithmic equation x is equal to the log base 4 of 64, and we've already seen that x is equal to 3 because we know that 4 cubed is equal to 64. Let's take a look at another example where we can actually solve for the value of x. So here we have 36 to the x is equal to 6. We know that the square root of 36 is equal to 6, or written using exponents, 36 to the 1/2 is equal to 6. So we know here that the x is equal to 1/2. Let's take this exponential equation, 36 to the x equals 6, and convert it to logarithmic form. Here our base b is 36, and our y value is 6. So rewriting this exponential equation in logarithmic form gives us x is equal to the log base 36 of 6, which we know is equal to 1/2, again because 36 to the 1/2 is equal to 6. So in these problems, we got some practice converting between exponential and logarithmic forms of equations. And again, the key to remember is that x equals log base b of y is just another way to express the exponential equation y equals b to the x. Let's do a few more problems evaluating logarithms. So here we have the log base 10 of 10,000. So remember that we're looking for a number x such that 10 to the x is equal to 10,000. So we know that 10 to the 1 is 10, 10 squared is 100, 10 cubed is 1,000, 10 to the 4 we know is equal to 10,000, so x here is equal to 4. So the log base 10 of 10,000 is equal to 4. As another example, let's look at the log base 10 of 0.1. So again, we're looking for a number x such that 10 to the x is equal to 0.1. 0.1 is the same as 1/10, which is the same as 10 to the negative 1. So our x here is negative 1. In other words, the log base 10 of 0.1 is equal to negative 1. Let's look at one more of these. Here we have the log base 5 of 1 over 25. Again, we're looking for a number x, so that 5 to the x, our base here is 5, is equal to 1 over 25. 1 over 25 we know is 1 over 5 squared. Using our rules of exponents, this is the same as 5 to the minus 2. So our x here is negative 2, and we get that the log base 5 of 1 over 25 is equal to negative 2. So in this lesson, we got some practice converting between the exponential form y equals b to the x and the equivalent logarithmic form x equals log base b of y, and we used these two forms to evaluate different logarithms.